Hey guys, what's up? Welcome to the final part in our video series on directed search. In this video, we are going to discuss efficiency in the context of Moen. Let's go. So the planner's problem in the context of Moen is where he's going and maximizing the following problem. Again, we have this integral here to communicate that time is continuous. And he's going to be picking the number of vacancies, the mass of unemployed workers, or number of unemployed workers, the cost for posting a vacancy, and the number of employed workers to be there across submarkets 1 to n. So this is why we have this second point for our sum, because we're summing over all submarkets. Subject to our employed law of motion. So there's two ways to go and think about this. We can think about it as an unemployed law of motion or an employed law of motion. In this case, we're thinking about an employed law of motion, which is defined by the number of people that go and find jobs minus the people that go and lose their jobs at any given moment in time. And likewise, by our vacancies, we have the effectiveness of going and filling those vacancies minus those that are now being posted again. And this next point down here is just a condition that since we're dealing with a mass of 1 workers, meaning that we have a measure of 1 workers, just that if we sum over all n submarkets, that's going to be equal to 1. Okay, so to solve this problem, we go and we write our current valued Hamiltonian. If you don't know what a current value Hamiltonian, I have a video on that. Just look up using the Hamiltonian in economics. I think we go through this in example 1, so that'll give you an overview of what this tool is. Taking our first order conditions with the above, we go and we get the following results down here. I just want to go and point out that in this one here, I kind of didn't really, make it so explicit here because remember, theta is equal to V, right? The number of vacancies over U. That's our labor market tightness. So I made it explicit in our last condition here, but not in this second condition here. But it still communicates the same idea here. It's just the same sort of result. Just I wanted to go and illustrate 2 different ways of going and thinking about it, even though the notation isn't quite consistent here. But it's the same good first order conditions. So if we rearrange our first order conditions for our first equation, second equation, and fourth equation, while noting that our partial derivative with respect to our firm's probability of them going and filling a job, we go and we have the following, that is theta q, theta eta here, right? Where eta here is from our Hosios condition, and we have the following results. So these equations here, they look very familiar, and we're going to make them look even more familiar as we go and we define our multipliers. So since these are multipliers, we're free to define their values however we want. So we can let lambda be equal to SI and gamma I, right? So this is SI, this is the joint surplus formed through a subject market match, and gamma I is equal to VI, which is the value of a vacancy there. And alpha here, this is just a regular multiplier, we're just going to define that to RUI. And we get the following result. If we do a little bit of math here, just making things simple, we can knock out these VI terms right here. And if we were to go and really bring this over to the other side here, right, this would just be equal to J over here. I know this isn't the best thing there. I don't have my draw pad plugged in. So let's go and think about what exactly this means, right? We're able to go and get some similar expression compared to our original framework that we've defined. So optimality in the context of directed search is where our wages in submarkets converge to our unemployed value, because remember right here by RUI in our planner's filled firms equation here, that's swapped out with RUI. And also from these other 2 equations, that being our vacant firm bellman and our unemployed worker bellman, we see that workers and firms transition to values that are, I guess, negotiated through Nash bargaining, where that weight is determined by Hosios's condition. So this is the complete story on Moen's directed search framework. I hope this video helps. Take care.